Before we start talking about geometry, it's important to have our basic definitions in place and symbolic notations. And this is kind of like when you do during the lesson, it's kind of boring because it's a lot of me talking and it's an easy enough to do via video. That's why I'm recording this video about basic definitions and symbolic notations in geometry. And we're going to start with the three most important terms here because everything is based off of those, pretty much everything. They are, however, so the point, line, and plane, they are, however, undefined terms. You cannot really give a definition of a point. Like, what is a point? Oh, it's this little dot that I drew. But what's a dot, right? We do know that point doesn't have a size. So if you just draw it, I'm going to start with the diagram over here. So you just draw it normally. It's just like a point, right? We all know how to draw it. It doesn't have, so when we look at it, it does have the size, but in geometry, we assume that it does not have any size. Line, so I'm going to say here, those are undefined terms. Undefined terms, all three of them. Symbolic notation for a point is just the name of the point. So if my point is named A, right, this is the name of the point, and symbolic notation is a name, it's a capital letter. So make sure that when you're labeling your points, they should be capital letters. Okay, line is another undefined term. We know very often you guys say, students say that, oh, it's a straight line. Well, the lines are always straight. If it's not straight, it's not a line, it's a curve. So a line is something that we label, let me see, do I have, okay, and then there should be an arrow on the other end as well that I'm going to draw like this. So this is a diagram. So for a line, we will have a line. It does not have a thickness. It's kind of made of points. So how do you get a line? You put bunch of points together, right? It's, as I said, straight. We don't usually say straight line. You would draw it using a ruler, straight edge, and then we put two arrows at the ends. So when I label a line, I would have to either have 2 points, say point A and point B over here. And then I would say that my line is called line AB, and then I put a little symbol of the line, so a two-sided arrow. It doesn't have to go from A to B, it can go from B to A, so my line can be called line BA, like so. Or I can also call my line by a single letter, lowercase letter, so I'm going to call it line L. And in that case, I don't put anything on top of that. So those are the notations for the lines. Capital letters with the two-sided arrow on top. Okay, for the plane, another symbolic notation. So plane is similar to relationship between point and line. So if you put bunch of points together, you will get a line. And now if you have bunch of lines together, they will cover a plane. What are examples of planes? A plane is a table is a plane, a wall is a plane. So it's some surface. Plane also doesn't have thickness, and it keeps on going forever and ever and ever. So table is an example of a plane, but it's not a plane because table will end somewhere. Same thing with the wall or a ceiling or like even the road outside. Yeah. So for the plane, we use a capital letter. I'm going to use M, so kind of like for a point, and we have to be very careful with the context so that we don't confuse those two. And for a plane, we usually draw something like a parallelogram like this, and then we say it is a plane M. So this is going to be our diagram for a plane. All right, now next one is ray. And let's draw array, write a symbolic notation, and then we're going to write down a definition for array. So array is similar to a line, but it does not have, it does not go both directions. So array will actually start at some point, and it is important to have this point first when we label it. And then it goes through some other point, and it keeps on going. Okay, so line was going both directions, ray only goes into one direction. So here when I choose 2 points, first one has to be the end point, beginning or end point of the ray, and then the second point can be anywhere. So my ray is called AB, and it is important when I'm drawing a symbol of the ray on top of it that A is where it starts. It does not have an arrow, and then B will have an arrow. It doesn't mean that you're going to draw B over here. A very common mistake is when students label the ray like so. They say this is A and this is B. No, 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 no. This is not a good idea because B is a point somewhere on the ray. So this one, I'm going to cross it out. That's not how we label rays. The point has to be somewhere, not at the arrow. So the arrow just shows that it keeps on going. It's not like the end of the ray. All right, now for the definition of the ray, it is array is made up of points on actually let's define segment first because I'm going to be using definition of a segment when I define array. So let's go to the next one and then we'll come back to the array. So for the segment, the difference between the segment and the array and the line is that segment, it will have both beginning and end. We call them endpoints, even though it's kind of like a beginning and the end. So the segment AB. So in this case, we put this point at the end, and then we say that our segment is called segment AB, and then we put a drawing of a segment on top, or we can call this segment BA. So in this case, just like with the line, it doesn't matter which point is like first and which one is the beginning and one is the end. Okay, now definition of a segment, proper definition of a segment. It is a set of points consisting of the distinct points. So I'm going to skip points, otherwise it's not going to fit. So set of points consisting of consisting of distinct points A and B, and all points between them, and all points between them, between them. So that's the definition of a segment. Now to define the ray, we would have to use a definition of a segment because we're going to say it is a segment AB and it is all the points beyond point B. So here's the proper definition. Points on segment AB and all points for which B is between each of them. So points over there. So B is between each of those points and endpoint A. All right, so this one is a little clunky definition. So all those points for which B is between each of them and endpoint A means all the points over there to the right from point B. One more thing that I wanted to point out about array is that even though I drew it in this direction, the array can be drawn in any direction. It can be going here, there, up, down. It doesn't have to go to the right, but still when we label our array, we would start with the point at the end point. Let's say this is C, and then you pick a point somewhere on the array, and then you will say, this one is my array CD, like so. So this ray is going to be called ray, let's do MK. So I have ray MK. So I find the starting point and then the point somewhere on the ray, and I always start with this point, yeah, and so on. All right, opposite rays. Opposite rays, they are going to be facing, well, opposite directions, but they're going to basically make up a line. So they are going to look like this. So this is one ray and it starts at the same point and it's not going to go up or down or anywhere. It's going to go exactly in the opposite direction. Mine is a little bit off. I hope that you will do a better job in your notebooks. So I'm going to label my rays A, B, and it's going to be A, C. So the definition for opposite ray is the following one. Ray AB and ray AC are opposite if and only if A is between B and C. So A is between B and C. Those two rays are opposite. Now, what about this notation? It might look a little bit weird. It is a commonly accepted abbreviation in math. It is used instead of words if and only if. If and only if. We will be talking a little bit more about conditional statements, what those are and what this means. So right now, in brief, that means that if those rays are opposite, then A is between B and C, and then also if A is between B and C, then those two rays are opposite. So that's what if and only if means, and the abbreviation is IFF. We just do I and then two F's here, IFF. So that's not a typo, it's an abbreviation for if and only if. All right, next term is collinear. So we have three or more points that are collinear if and only if they are on the same line. So if I have my 3 points going like this, right? You can see they're not collinear. I cannot draw a line through those. However, if I were to draw my 3 points like this, now I can draw a line through those 3 points, and those 3 points are going to be collinear. So see how I can draw a line through those 3 points. I'm going to label the ends, and let's write down the definition for this. Three or more points are collinear if and only if they are on the same line. I went a little bit over here. So once again, three or more points are collinear if and only if they are on the same line. So you see, it's applicable for three or more points. So I can have 3 points, I can have more points here, I can have another point over here, another point over here. As long as they are on the same line, then we say they are collinear. Why is it 3 points? Well, because imagine if you have 2 points, can you draw a line through them? Well, yes, you can. So for 2 points, it doesn't make sense to use this definition. For coplanar points, very similar to collinear, but now we are using 4 or more points. So we have our plane, and then we have 4 points. Maybe they're located like this. It's kind of like hard to draw, but you can imagine that you can draw a plane through those, and the definition is going to be very, very similar to 4 or more points are coplanar if they are in the same plane. So 4 or maybe even more points. They are coplanar if they are in the same plane. This one says more. Figure. Figure is a set of points. Very simple definition. If you have a points kind of like placed together. So a set of points is a figure. We will be talking specifically about triangles, quadrilaterals, so some special figures, but your figure can be like a blob, right? It's a figure. It's a set of points. We can have special triangles, we can have like right triangles. Okay, that does not look very right. We can have quadrilaterals here, all the different types of shapes, pentagons, whatever. Everything that consists of points is a figure, and the name for the figure, we just use the names of points and we put them in order. So a, B, C, D is going to be a name of, say, this figure. If I start labeling it, so I usually start labeling in either clockwise direction or counterclockwise, but the letters, they have to follow each other. So if I call this one B, then this one has to be C, and this one is D. Or vice versa, if I have a figure like this and I start A and then B, then this point will be C and this point will be D. What I cannot do is I cannot say, oh, A is going to be here, B is going to be there, C is going to be there, and D is going to be there. So this name is now going to be A, D, B, C, or A, C, B, D. So that's the name of this figure, right? If I have A, B, C, D, then I have to place those in order, either clockwise or counterclockwise. Space is a set of points, but a set of all the points possible, all the points out there in the universe, right? It's your notebook, it's your pen, it's your computer, it's your table, it's you, it's all the trees around you. So everything makes up a space. There is no diagram for it. I mean, how can you draw a space? And the definition for it, it is a set of all points. of all points, everything, yeah, of all points. Final definition for today is distance, and actually, ironically, it's not a definition because distance is also an undefined term. It is undefined term. It is, however, is a number, so we have to remember it is a number. Because think about it, if somebody is asking you, what's the distance between your house and the school? You're going to say, oh, 2.3 miles. Or you're gonna, somebody is asking you, what is the distance between, I don't know, yourself and the door? You're gonna say, oh, it's 5 feet. You always give a number. So the distance is a number. And the distance between 2 points, so if you have a point A and point B, the distance between them, this is not really a notation. There is not like a good notation for it, but the distance is going to be in symbolic notations. It's going to be AB, nothing on top, not the arrow, not the line, nothing. So it's a number, and that's why it doesn't have anything on top. So this one, I'm just showing that that's going to be the distance for AB. I'm actually going to erase it because it's not really a diagram for the distance. You cannot have a diagram for the distance. So the distance, you can say AB equals 5 feet, right? Or you can say that AB equals 2 miles, the distance from, I don't know, on the big scale, right? So that is that. So those are your basic notations, basic definitions, symbolic notations. And if you cannot read my handwriting, if you need to go back and write something else, then actually I have over here, you can pause this video, and over here I have this table with all the definitions written down, typed out. So if you need to look at those in more details, you are free to do so. I have everything except the diagrams here. Okay, so you can pause the video, write them down if you could not read my handwriting, and that is what you need to have by tomorrow in your notebooks, this table with the diagrams. So have fun with that, and then we will be practicing tomorrow with all those terms. All right, bye.